Hi there, grade 12s, and welcome to today's lesson on statistics and transformations. I hope you guys are all ready for it. You know that this is part of your paper 2, and it's actually quite a fun and interesting part of paper 2, so I hope you guys learn a lot today and enjoy this section. Right, what we're going to be looking at is questions that we've adapted from various past papers, and we're going to be starting with transformations. Okay, now transformations, grade 12s, is a section that we've dealt with throughout your high school, and you've learned a lot of rules with regards to your transformations. Now, this is something you need to go and study, okay? All your rules regarding the reflections about an x and a y axis, the reflection about the line y equals x, your rotations, your enlargements, all of those rules of transformations are really important, and it's a good theory that you must go and study, okay? Right, let's have a look at what our question that we are going to be working through today has to say, and obviously we'll show you how we're going to apply those rules of transformations, okay? Let's have a look at what the first one has said to us. They have said that the following transformation is applied to all points. Firstly, this is the first point that they're talking about. A point is translated by 4 units to the right. Okay, so basically this question is breaking your transformation down into 2 stages. The first stage is that we are doing a translation being a movement where we're just changing the position of your point. And then once we've done that, we're going to be doing a rotation. So the first part of it, the way we're going to write it is that my original point, or my any point, is the point x and y. Okay. Now the way we write it is we draw ourselves an arrow indicating that there's a transformation occurring, and this transformation is saying that it is translated 4 units to the right. Now looking just at this first translation over here, 4 units to the right would imply that my x values are all going to move 4 units up. So therefore we are going to be adding 4 to each one of your x coordinates. At this point, nothing has happened to the y coordinate. So where my xy has moved to an x plus 4, the y coordinate is not changing. So that would represent the first stage of the transformation of your question. Then we go on to say, now there's a second stage to the transformation, and that is saying that it is then rotated through the point 180 degrees about the origin. Here, grade 12s, is where your theory comes in, okay? If you know your transformational rules, we will know that if we've got a point xy, if we are rotating it 180 degrees about the origin, okay? Now, something interesting quickly about 180 degrees is that whether you rotate it clockwise or anti-clockwise, we are getting to exactly the same point. So it doesn't make any difference which way you are going there. But when we are rotating 180 degrees about our origin, what happens to our coordinates of x, y is that they become negative x and negative y, okay? So going from what we've had, we've established that I had x plus 4 as the x coordinate and y as the y coordinate. And this is now being rotated 180 degrees. So what is then going to happen to the x coordinate? What we know is that the x coordinate becomes negative, and the y coordinate also becomes negative. So therefore, what would my coordinates be if I've moved 4 units to the right and I've rotated about 180 degrees? I would have a negative x minus 4 as the x coordinate, and I would have negative y as the y coordinate, okay? And that coordinate, that coordinate pair over there is indicating or describing the transformation that has occurred here, where we translated it 4 units to the right and then rotated it 180 degrees about your origin, okay? As I've said to you, please learn that theory, okay? It's not something that's too difficult, and if you have it at your fingertips, it makes this kind of question very easy and nice to do, okay? Right, that is then dealing with it as just a normal rotation of 180 degrees. Now, this year, adding on to your normal translations, we don't just only rotate about 90 degrees or 180 degrees. We can actually rotate about any degree about the origin, okay? And we have a special formula that we apply when we are rotating about any point around the origin. Let's have a look at what our question has said over here. we've got point Q, and this little dash over here, remember, indicates the image of point Q. So that is already the translated point, okay? So point Q is the image of our original point Q after a rotation of 135 degrees in an anti-clockwise direction about the origin. So what they are asking us to do here is to calculate the coordinates of Q, and they're wanting us to leave our answer in surd form. Okay. Right, grade 12s. The first thing we need to be aware of is in the formula that we are going to use when I'm rotating any degree about the origin is as follows. To work out the x coordinate, we say I've got x cos theta minus y sine theta, and that's going to give you the image of the x coordinates. And the y coordinate is going to be y cos theta minus plus x sine theta. Okay, so that's the formula that you want to have, again, at your fingertips. It's one of the formulas I want you to learn and be familiar with so that you can immediately write it down as soon as you see a question like this. And from here, it's a case of subbing in and applying it. Okay, right, so this question has said that we've got point Q, and point Q is actually the original point Q is rotated already to my new point of Q, which is -2 and -3. Okay, so, and the rotation, the degree was 135 degrees. So this is what the idea would be. If my point Q is at -2, -3, that's my rotated point Q. We were told that this point was rotated 130 degrees in an anti-clockwise direction. So this was already rotated in 135 degrees. Actually, no, it'll be slightly less than that. It's just 135 degrees. Okay, so from the original point Q, which we're estimating is around about there. Okay, and it's a 135-degree rotation. So what the idea is over here is that if point Q is actually the point that is known, to go back to the original point Q, we're going to have to go in the opposite direction. Okay, so this is the story. We're going to be going in the opposite direction, and if we're going in that direction over here, this would be considered a clockwise direction. Okay, now, when we are subbing points into our formula, when you are working in an anti-clockwise direction, remember when we work in our Cartesian plane, to work in an anti-clockwise direction is your normal rotation, okay? And if we're going in an anti-clockwise direction, you will always actually substitute the positive angle into your values for theta. However, if you're going in a clockwise direction, which is in fact going against the normal rotation around your Cartesian plane, we then substitute in a negative angle into your thetas, okay? So because we're going from your image of Q back to the original point of Q, we're actually moving in a clockwise direction here. And because of that, into your thetas, because we're going around an angle of 135 degrees, because we're going in a clockwise direction, I'm going to substitute negative 135 degrees, okay? All right, so let's put together what we've got. We know that our image of Q was -2, -3, and we are going in an anti-clockwise direction because we're going back to the original point of Q, and it's of 135 degrees. Okay, so let's start with our image of X. To get back to our X, the original X coordinate, we are going to say, but let's just write our formula first. It's going to be X cos theta minus y sine theta. I'm going to use just the X side for now. We'll deal with Y in a minute. Okay, so what we know is I'm going to calculate the coordinate X by saying the X coordinate of my image of Q was -2. So I'm going to substitute in -2 into my X cos of theta. But remember we said that it's going to be a negative theta because we are going in a clockwise direction. The value for y that we're working with is a -3, and it's going to be sine of -135. Okay. Right, okay, so now all we've done, I'm sure you can see, is we've substituted the coordinates of x and y, and the angle of rotation into your formula. From here, guys, it's a case of just careful working out. Okay, let's have a look and see what we get when we work it out. -2, let's take this one step at a time. Negative 135 degrees, remember that would indicate that we are in our fourth. Anything that's a negative angle is quadrant 4. Now cos in quadrant 4 is actually positive, so that will become a positive cos 135. These two negatives, negative times negative is going to make positive 3. And then sine of negative 135, once again, quadrant 4 would imply that sine is negative. Okay, so therefore, I'm actually working with a negative sine 135. And let's just write it like that so we can then sine of 135. Okay, right, let's tidy that up just for a second. So therefore, I've got -2 cos 135. My -3 times by the positive 3, times by the negative sign is going to give us -3 sine 135. Okay, now we need reduction formula. 135 degrees is going to be the same as saying 180 minus 45. Okay, 180 minus is quadrant 2, and in the first case, I've got a -2, and then I've got cos of 135. Cos of 135 is the same as, with reduction formula, negative cos 45. Okay, we did reduction formula there. The reason it's a negative cos is because cos is negative in your second quadrant. Okay, I've got my -3. Sine of 135, remember quadrant 2, sine is positive, so that can reduce to just sine 45. Okay. Right, so one more stage of tidying up, and then let's simplify. So the two negatives here are going to make positive. So I've got a positive 2 cos 45, and I have got a -3 sine 45. 45, remember, is obviously a special angle. And the special angle of cos 45 is root 2 over 2. And the special angle for sine 45 is also root 2 over 2. Okay, so let's see what that gives us. I'm landing up with a 2 root 2 over 2 minus a 3 root 2 over 2. Now, essentially, 2 root 2 minus 3 root 2 is going to land up giving you -1 root 2 over 2. And that, grade 12s, is your x coordinate, okay, of the original points from the translated points of Q. Okay, so that's just the x coordinate. Now we need to work out the y coordinate. So let's go back to the equation. Let's just quickly zap back to here and let's have a look. Remember, to work out the y coordinate, we use the y cos theta plus the x sine theta. So let's go down and let's work that out. So to work out our y coordinate, we're going to say y cos theta plus x sine theta. Again, remember your image of Q was the coordinates of -2 and -3, and you had that 135 degrees in a clockwise direction, so once again it will be negative when we sub it in. Okay, the y coordinate is a value of -3. Theta is -135. The x coordinate is -2, and I've got sine of -135. So once again, grade 12s, we need to just slowly go through it and just carefully sift our way through all the negatives and getting rid of signs and what have you until we have reduced it down to what we need it to be. So once again, -135 is quadrant 4, and our cos is positive in quadrant 4. However, there is a -3 sitting in front of that cos, so therefore it's going to be -3 cos 135. Okay. Right, then I have a -2, and I've got sine of 135. Now, sorry, -135, which is quadrant 4, where sine is negative. Okay, so sine of -135 is negative, and I do actually still have a negative of 2 sitting in front of it as well. So the two negatives are going to make +2 sine 135. Okay. All right, so let's simplify. We've got y is equal to negative 3. Cos of 135, once again, is the same as doing our reduction formula of 180 minus 45. 180 minus is in quadrant 2, where cos is negative. So that negative combined with the negative in front of the 3 is going to make positive cos 45, okay? And sine of 135 is in quadrant 2, where sine is positive. So therefore, the positive that is already in front of my value, multiplied by another positive, will just stay plus 2 sine 45. Okay, that's probably the hard part done. Now we have to sub in our special angles. Cos of 45, again, is root 2 over 2. And sine of 45 is root 2 over 2. Okay? So when we simplify this, I'm going to have 3 root 2 over 2 plus 2 root 2 over 2. And again, if I've got 3 root 2 plus 2 root 2, it's surds. You've got like surds, so you can add them together. 3 root 2 plus 2 root 2 is going to give you 5 root 2 over 2. Okay, and that, guys, is going to be the coordinates, the x and the y coordinates of your point Q. So let's just fill it in finally. So point Q, remember the x coordinate was negative 1 root 2 over 2, negative 1 root 2 over 2, and the y coordinate was 5 root 2 over 2. Okay, it did tell us to leave it in surd form, and just as a word of advice, you can very much expect your answers in a rotation sum like this to be very full of surds and sometimes look a little bit complicated, okay? Expect that. But in terms of the working out, guys, it's a case of being careful and just being thorough and making sure that you're not making any silly mistakes. Other than that, you're subbing it into your formula, and that is really the important part to remember. So that is theory, and guys, that really does need to be studied, okay? Okay, right, we are going to, have a short break, and when we come back, we're going to have a look at statistics and all the different aspects that make up your statistics section. So don't go away, we'll see you now. Hi, grade 12s, and welcome back. Okay, we are going to now have a look at the statistics part of your paper 2, and just to give you a brief overview, the things we're going to be dealing with in statistics is your mean, your median, your mode. I'm sure by now we all know that well. Then we're including things such as your box and whisker diagrams. We've got our cumulative frequency, we've got standard deviation, and we've got scatter plots, okay? And those are the different parts that are going to make up the questions when you do your statistics paper, okay? Okay, so let's have a look, first of all, at quite a nice question from one of our past papers, and it deals with all the different parts of our data. So when we talk about the maximums, the minimums, the medians, and all of those numbers, this question deals with all of those quite nicely. So what the question actually says is, they've given us a grid, and inside the grid, as you can see, they've filled in A, B, C, D, E, F, and G, and they've said that they represent values in your data set, and they've told us that it's been written in increasing order. Okay, and the other thing they've said is that no value has been repeated, so therefore we know that we can't have two of any of the same numbers here. Okay, so the first thing they've told us is that the maximum value of our number set is 42. Now, if this set of data has been given to us in increasing order, I hope it would make sense to you guys that your last number, your G, is going to be the biggest number in your data set. So first things first, I can see that G is actually going to be 42. Okay, so in fact, let's fill it in over here. Okay. The next thing they've said is that the range is 35. Now, what's important about this is that we need to remember what is being applied when we talk about range, okay? Your range in a set of data is your highest value minus the lowest value, okay? So therefore, if my highest value is 42, and my lowest value is obviously the very first number here, which is obviously A, that's giving me a range of 35. Okay, so that's just a normal equation we can solve for. We can say that, let's bring our 35 to the left, and let's take our A to the right, And 42 minus 35 is giving us a difference of 7. So therefore, the lowest value in your number set is actually 7. Okay, so we can fill that in over there. All right. Now they've said to us the median is 23. Let's quickly talk about the median. The median, remember, is your middle value, okay? And in order to get that middle value, your data must be arranged in ascending order. So in other words, from smallest through to biggest. And once it's in ascending order, your median is your middle value, okay? Remember that another way we actually refer to median is as your Q2. So just remember that if you ever see that Q2, we are referring to your median, okay? So therefore, if we look at our data, I have 1, 2, 3 numbers on the left-hand side, and I've got 1, 2, 3 numbers on the right-hand side. And can we see the D actually falls right in the middle of those the two sides of your data set? That would give us D as the middle value. It would be the median. And they've told us that that is 23. So my Q2 is 23. Okay, so we're getting somewhere with this. We're filling in our values. Now they have said the difference between the median and the upper quartile is 14. Right. What are the quartiles? We've got our Q1, we had our Q2, Q3, and then you had your minimum and your maximum. Okay. Remember, your quartiles is essentially taking your data and dividing it into 4 equal parts. Okay. So if we've calculated your median, to work out your Q1, we are essentially working out the halfway mark of the first half of your data. And to work out Q3, we are working out the halfway mark of the second half of your data. Okay? So Q3 is then the upper quartile. Okay? Let's just write that. Where did we? The upper quartile, which we know is Q3. Okay. Now let's look at this. This over here would be the upper half of my data. And the halfway mark between those in that upper half is actually going to be your F. So therefore your F is going to represent your Q3, and they have told us that the difference between your median and your upper quartile is 14. So therefore your upper quartile minus your median, which was 23, is equal to the difference of 14. Right. So when I bring that over, my F is going to land up being 14 plus 23, which is 37. Okay, so that over there gives us the value of 37. All right, I hope you guys are following. Now they're saying the interquartile range is 22. Okay, you can see why this question is actually a very good question, because in one question it's really covering all of this information. The interquartile range, remember grade 12s, is the difference is your Q3 minus your Q1. Okay, and they are telling us that that in this case is 22. Now what do I know? I know that my Q3, let's just give ourselves some space over here. The Q3 we know is 37. We've just worked that out. So therefore 37 minus Q1, they're telling us, is 22. Now looking at my first half of the data, point value B is going to be Q1, because that's the halfway mark between the first half of your data. So therefore, if we work this out, I'm going to work out my value for B to be, if I take my Q1 to the other side, and let's bring 22 over, so therefore essentially 37 minus 22 is equal to Q1, and that is giving us a value of 15. All right, so Q1 is 15. All right, we're getting there. Okay, so the last two values to solve for are your E and your C. Okay, so let's see what it is that we know. Okay, I need to solve for C. Okay, and for C and for E. What have I been told about the mean? The mean is 25. Now that's quite interesting over there, because the mean would imply that in order to find the mean, you would have to multiply, or not multiply, you would have to add all the values in your data set together, and you divide it by the number of terms that there were. So let's see if that helps us out over here. They've told us that E is equal to 2C. So what I'm going to do, guys, is I'm actually going to cancel out that E over there, and I'm going to replace it with a 2C. Okay? And let's see then what we've got. To work out your mean, I would have to take my 7 plus my 15 plus my C plus my 23 plus my 2C plus 37 plus 42. And that's all going to get divided by, so let's put that all over, the number of terms that there are. And how many terms are we actually working with over here? We have got 1, 2, 3, 4, 5, 6, 7. So therefore, we're going to divide it by 7. And remember that this is all equal to the mean of, they told us, which was 25. So we're making this whole thing equal to 25. Okay. Right, guys, so now is a bit of time for adding. You need to take all the terms that you can add together and add them together. And obviously the C and the 2C are going to get added together. So when I add it all together, first of all, my C plus my 2C is going to give me 3C. So we're going to just give ourselves some space and write it here. So therefore, 3C is what we get when we add up all of those terms. And when I take my 25, which is on the right-hand side, and I subtract all the values that we know on the left-hand side, we actually land up with a value of 51. Okay, so that's a case of just solving and rearranging your equation. And from here, it's a case of dividing by 3 and solving for C. And if we solve for C, we should land up with 51 divided by 3, which is 17. And finally, don't forget that they told us earlier that E is equal to 2C. And if E is equal to 2C, that would therefore mean that E is equal to 2 of 17, which is 34. Okay. Right, so that was actually a really good question, guys, because it really covered all the little bits and pieces of all the types of data that you get in your data set and how you use it. Okay, very quickly, this question did then ask us to sketch a box and whisker diagram. Okay, a box and whisker diagram. In order to sketch a box and whisker diagram, remember what you need to start off with is what we call your 5-number summary. Okay. Now remember, your 5-number summary is made up of the following. The first thing is your minimum value. So you always state your minimum value first. Then you find your Q1, which remember is your lower quartile. Next, you find your Q2, which is your median. Let's just write there that that's your lower quartile. And Q2 is your median. Okay. The next thing we have to write is Q3, which remember is your upper quartile. Okay, and finally, once you've got that, you write the maximum value. Okay. The minimum value in our data set, remember, was 7. The maximum number is 42. So let's fill that in over here. So we've got 7, which is the minimum, and I've got 42, which is the maximum. My Q1, Q2, and Q3 are 15, 23, and 37. So 15, 23, and 37. So this is how we are going to represent this on a box and whisker diagram. The first thing you do, please, is you draw yourself a number line, okay? And on that number line, we fill in our values, okay? So starting with, let's get our pen. Starting with, let's go up in 5. So I've got 5, 10, 15, 20, 25, 30, 35, 40, and 45. Okay. Your minimum value was 7. So on your box and whisker, where 7 is, you're going to put your first dot. Your maximum value was 42, so 42 is going to be a sort of estimated there on your number line, so that's going to be your 42. Let's just fill that in underneath there so that we know that that's 42. Okay. Your Q1 is 15. So now at your Q1, the way we need to indicate this is you actually need to draw yourself a line above the Q1. Your Q3 is 20, your Q2 is 23. So you're going to draw a line above 23. And your Q3, your upper quartile is 37, so you're going to draw a line above there to represent your 37. And you box those off like so. Okay. And let's just move that up so it looks a little bit better. Okay, there we go. And once you've boxed that off, remember this represents, that over there represents Q3, and this over here represents Q1, this represents Q2. So do you agree with me, guys, that that over there represents your interquartile range? That's your Q3 minus your Q1. And finally, what you do is we draw a line from our box to our maximum point and from our box to our minimum point. And what is crucial to remember about your box and whisker diagram is that each part of your box and whisker indicates or represents 25% of your data set. So it doesn't matter if one part of your data is bigger or smaller than the other. Each one is representing 25% of your data. What the important part is about this is that it's representing the spread of your data in each of those 25%. And how does that affect your average in relation to your median? If I were to look at this data set, just having a look at it, if you were asked to determine what kind of skew we're dealing with over here, what I can see is that I've got a very big range of data in my upper quartile. So what I'm going to take from this is that your median, your 50% of your data is sitting from 7 to 20. And the second 50% of your data is going from 20 to 45. So therefore the conclusion we can make is because there's a bigger spread of data on the upper side of your median, it is going to make the mean slightly higher than your median, okay? So therefore, as a result, we are going to refer to this as positively skewed. And what we're taking from that is that your mean, your average, is going to be slightly higher. This is not a very skewed set of data, but the mean will definitely be slightly higher than the median in this particular box and whisker. Okay. All right, guys. That is then also a very important part of your data and something that you need to always go and practice. Okay, a very common question in your exams. All right. Let's quickly have a look at working with standard deviation. This actually can be done on your calculator, guys, and that makes your working out a lot quicker. All right, let's quickly look at our example. The scores for 8 golfers who played a single round of golf on the same golf course are shown as follows. And we've got the 69, 71, all the way through. Okay. And they've said to us calculate your mean scores. Now, this is how you are going to work out your mean scores. Let's move it out so we can... Okay, we're going to work out our mean scores on the calculator. You are going to press your mode and you're going to press 2 for stat. Okay, once you have done that, the option we want is 1 for the variance, and now we are going to type in our numbers. The first number we had was 69 equals. We then have 71 equals. I've got 75 equals. 74, 78, 70. Okay, let's just move this over. Then we've got 72 and we've got 71, and there's our data set. So once you've got that, what we do is we press AC Shift 1. All right, and that's going to bring up all your different variations that you're going to choose, and the one we are interested in is number 4. And if we're looking for your mean, guys, remember X bar, number 2 is the notation for your mean. So therefore we press equals, and it's 72.5. So the mean score for your data is going to be 72.5. Okay. Now they're asking us for the standard deviation of the data. Remember, your standard deviation is essentially saying this. You're working out your average of the data. Now, the standard deviation is looking at each individual piece of data and calculating the average deviation of each piece of data from the average. Okay. So, I know you guys learned the long way, the formula that we used for standard deviation, which is as follows. We have to take the square root of the sum of our x minus our x bar, which is our mean, squared all over n. Okay, that's our formula that we use for standard deviation. However, it is much quicker to put it into your calculators. Okay, so then we'll take out our calculator and let's type it in. Remember, we start with mode, 2 for stat, and number 1. Okay, we're back to our table. And we type in each of the individual pieces of data. So 69, 71, 75, 74, 78, 70, 72, and 71. Okay. Remember, once we've done that, I want you to press AC, Shift 1, and we press 4 for variance, and we want 3 for standard deviation. And we get 2.78 rounded off to 2 decimal places. So your standard deviation is going to be 2.78. Okay, so the average deviation of each person's score about the mean is a 2.78 difference on either side of your mean. Okay, so therefore, knowing that, the next question then says, how many of the golfers' scores lie outside 1 standard deviation of the mean? Now remember, 1 standard deviation was your 2.78. So let's just think about this for a second. The mean, your average was 72.5. Okay, so if that's your mean of 72.5, 1 standard deviation up from your mean would be, can't remember the standard deviation, 2.78. We're going to add 2.78 onto that. And 1 standard deviation down from the mean we would take away 2.78. So let's just work that out here. So let's take let's go back to our normal calculator. And we're going to take your mean of 72.5, and I'm going to add 2.78 onto that. Well, that gives us 75.28, right, 75.28 on the upper side, and if we subtract it, if we take our 72.5 being your mean and I minus 1 standard deviation, I get 69.72. 69.72. So let's see who does fall inside the standard deviation, and then let's see who's left and who doesn't. If I've got just 69, now the lowest value on the lower side of my standard deviation is 69.72. So this one over here doesn't fall into the standard deviation of the mean. 71, if my range is from 69.72 to 75.28, that does fall in my standard deviation. 75 will fall in my standard deviation. So will 74. 78, that's going to be too high. Okay. 70 fell within it. 72 fell within it, and 71 fell within it. So the person who scored 69 and the person who scored 78, both of them were too high or too low in terms of the average deviation from the mean of those guys' golf scores. Okay, so standard deviation is actually a really nice way to measure the consistency of someone like a sports person, to see if their standard deviation, to see how consistent they are in terms of something like golf shots. So there we go. It's something for you to do on a Sunday afternoon while you're watching the golf. You can work out their standard deviation. All right, guys, we're going to take a short break, and after that, we will continue with a bit more stats. So see you shortly. Welcome back, grade 12s. Let's get going with the last part of our statistics, where we're going to be looking at your scatter plots, your cumulative frequency, and interpreting your ogive graphs. Okay, let's have a look at the example they've given us on scatter plots. And remember, scatter plots is helping us to determine a relationship between two variables. As the one increases, does the other increase, indicating a positive correlation of a relationship? Or as the one increases, does the other decrease, in which would indicate a negative correlation between the relationships. Okay, so let's see what we've got here. A group of learners was randomly selected from a class. The performance of these learners in a standardized test, which counts at 150 marks, and the average number of hours they spent watching TV each week was recorded. The data represented in the scatter plot below. Okay, so this is the data that they've given us over here. The horizontal axis represents the average number of hours spent watching TV, and your vertical axis is the test scores that were obtained in the test. The first thing they want us to determine from this diagram is what is the lowest score for this group of learners. Right, well, let's have a look here. If I take the very lowest value all the way along, I hope you guys can see that that there would be my lowest value, and it's going all the way to 30. So what would my lowest score be in my test? I think we all agree that it would be 30. Okay, out of 150. Hey, that was the test mark. So 30 is our lowest score. That was relatively easy to read off our graph. From here, they want us to know, does the data display a linear, quadratic, or exponential relationship? If we look at the data, we can agree on this. It's very much tending towards a straight line, okay? There or thereabouts, your values are very much grouped around that linear relationship. So therefore, of the three options that they have given us over here, we're going to say that our relationship is a linear relationship. Okay, right, so once again, easy enough to read off your graph. Okay, now the question says, what conclusion can be reached about the learners' test scores and the average number of hours they spend watching TV? Let's first of all look at that line we just drew through the points. This over here is what we call the line of best fit, okay? Your line of best fit, guys, it is an estimation. It's not going to be exactly 100%. However, the idea is that you want to draw your line as much through the middle of your different points as you possibly can, okay? And that will give you your line of best fit. Now, when we're working with a scatter plot, if your line of best fit is going down in a negative gradient, in a negative direction, that is indicating that you have a relationship between the two variables where the one of the other is going to correlate with the less of the other one. So the more of one, the less of the other. Okay, so this is the conclusion that we are going to deduce from a gradient facing in a negative direction, that the more TV the learners watched, the lower their test scores, okay? I'm sure if it was watching Mindset, it wouldn't be the case, but this is what these guys were watching, and it was obviously not having a positive effect on their averages. So that is a negative correlation. Just so you guys know, if your points do anything in the shape of this, if I just very randomly give you a couple of points, but what you can see is that in this case, they're actually going up in a positive direction. So if I were to draw a line of best fit between those green points, you can see that we're then going in a positive direction, and that would imply that the more of the one variable, the more of the other. The longer the hours that were studied, the higher the marks in the test. Okay, so that being an example of a positive correlation. Okay. Right, and then they're asking us, another learner from the class watches 35 hours of TV per week. So given the information, predict his or her performance in the test. So once again, we need our line of best fit. So we're going to put our line of best fit through the points. And again, just try your best to really try and make sure that you've got an even spread of points on either side of your line of best fit, okay? Right, now they've said to us that he watches 35 hours of TV. So we're going to go on our horizontal axis. That represents the number of hours watching TV. And we're going to go to 35. So 35 hours watching TV. And we're going to draw a line up to where it meets, where it meets your line of best fit. And from that point, we are going to then go across. So where it meets your line of best fit, we are then going to go across. Now, obviously, it's an estimation, so your answer will be accepted as sort of a range between a certain set of values, and we can estimate that he's probably achieved around about maybe 62% for his test, and that's going to be our estimation based on our line of best fits and our connection between the two axes. So therefore, 62, in fact, no, I don't think it's percent, it's just 62 out of 150. 62 is, I'm going to say plus minus 62 as his performance in the test. Okay, so I hope you guys understand that. We literally just went up and across and we read the data off the graph. If you guys are asked to draw one, you know what it needs to look like. You're going to have all your little dots scattered around. You're going to have your line of best fit through the dots, and that will indicate a positive and negative relationship, or possibly no relationship at all. And if there's no relationship, what you're going to find is that your dots are completely scattered everywhere, and there's no tendency one way or the other, and that would imply there's no relationship there. Okay. Right, guys. The next part of our statistics that we need to look at is our cumulative frequency. Okay, so let's have a look at what the data is that's been given to us. Just to note that the data being given here is not your discrete data, but it's actually grouped data. Okay, they're giving us they're giving us categories, each one of these representing a category. 30 learners were asked to answer a question in mathematics. The time taken in minutes to answer the question correctly is shown in the frequency table. So therefore, from 1 minute to anything less than 3 minutes, 3 learners achieved that time score. From 3 minutes to anything less than 5 minutes, okay, that could literally be 4 minutes and 59 seconds. That would still fall into this category over here. 6 learners achieved that score, and so on, okay. So the question is asking us to construct a frequency table of the data, a cumulative frequency table of the data. So in your cumulative frequency table, you're adding on an extra column, all right? And this is what you need to fill in your extra column. The first cumulative frequency block is going to be exactly what this first number is. Those two numbers are always going to be the same, all right? So that we know. To then get your second block in the cumulative frequency, you take the cumulative frequency on the first block and you add it to the frequency in the middle. So therefore, 3 plus 6, which gives us 9. Okay, let's get rid of that. Right, so it gets us to 9. We then do the same thing. We take 9, and I add it to the 7 in the frequency column, and that will give me the next cumulative frequency of 16. We take 16, I add it to 8, and it gives me the cumulative frequency of 24. 24 plus 5, so our cumulative frequency of 24 plus our frequency of 5, and that gets us to 29. And finally, your 29 plus your 1, and that gets us a cumulative frequency of 30, okay? A quick checkpoint for yourself is that the final amount in your cumulative frequency table has actually always got to add up to the total amount of numbers of sets in your data. And remember, we were told that there were 30 learners. So that, in fact, will then be the correct cumulative frequency table, okay? Now from here, we draw a cumulative frequency graph, which we call an ogive or an ogive graph, okay? Your ogive graph very much looks like an S-curved graph, okay? And it represents your cumulative frequency. Now, the coordinates that we use to sketch the cumulative frequency are going to be as follows. Right, we've got it in your... to get the x and the y coordinates of each one of your points on your ogive graph, you need to take the upper limit on each one of your categories. So the upper limit in my first one is going to be 3. So that's going to be the x coordinate. And the y coordinate is always the cumulative frequency value. So the first coordinate we're going to plot is 3 and 3. The upper limit in this category is 5, so therefore that's going to be my x coordinate, and the y coordinate was 9. Okay. We then had the next one, which was 7, and that cumulative frequency was 16. The next is 9, and the cumulative frequency is 24. 11, and its cumulative frequency was 29. And 13, and the cumulative frequency was 30. Okay, and we now plot these points on the diagram, which is usually given to you in your exam. You're usually given the grid that you are going to plot it on. Okay, so your first point was 3 and 3. So Your x-axis, I'm going to go 2, 3 on my x-axis, and I'm going to go up 3 on my cumulative frequency, and there's my first graph, my first dot at least. The next coordinate was 5 and 9, so 5 and 9 is going to be over there. Followed by 7 and 16, so 7 and 16 is going to be there. 9 and 24, so 9 and 24. So there's 20, so 1, 2, 3, 4. There should be 24. And I've got 5 and, I've got 11 and 29. So 11 and 29. Okay, that's going up to there. And finally, we've got 13 and 30. So 13 and 30, which is going to be over there. Okay. Right, the starting point, the way we call it the grounding point, is going to be the first point that we had in our categories, which was 1, and we're going to plot that at 1 and 0. Okay, so that's our grounding point over there. You don't join these points with a ruler, please. You just draw it with a smooth curve. So your ogive is going to therefore go from there to there to there. And as I said, you can sort of see for what it's worth that it has a very slight S-bend curve over there. All right, and that would represent the ogive graph representing the time in minutes it took for the learners to, the cumulative frequency of the time it took for the learners to answer that maths question. Okay, right. From there, there's now a question asking us to interpret data off that. Okay, so it says if a learner answers a question correctly in less than 4 minutes, then he or she is classified as a gifted learner. So estimate the percentage of gifted learners. So correctly in less than 4 minutes. So let's go back to our diagram and let's find 4 minutes. Okay, so 4 minutes is going to be over there on my axis, and I'm going to draw it up to my graph, and then I'm going to draw it across to my cumulative frequency. Okay, so the question said, how many learners are answering your question in less than 4 minutes? Do you guys agree that that is getting us to 6? Okay, so there are 6 learners who are answering that question in less than 4 minutes. So therefore it says, what percentage of your learners are considered gifted? Okay, well, that's obviously 6 learners out of a total of 30 learners, okay? And that would then, to work it out as a percentage, is just timesing it by 100. And let's see, so you've got your 6 out of 30, and to work it out as a percentage, we land up with 20%. Okay, so 20% of your learners are considered gifted learners, okay? From that diagram, the other types of information that you are able to get off an ogive curve is stuff like your median, okay, your estimated median. The way we would go about doing that, they haven't asked me to do this in this particular example. I'm just giving you an example of it. To find your median, you're going to find your halfway mark between your 0 and your 30. So therefore, I would take my Q3 and I would read it across, and we would go down, and we could say that the median time in terms of answering the question was roughly, what is that going to be, about 7 minutes. So that's an example of reading your median off your ogive graph. Grade 12s, your statistics is a section which I really believe you guys can do very well in. It's actually a really fun section, and what's great about it is that you do have the tool of your calculator, which is there to help you with all the finicky working out that does come up when we're working with statistics. So guys, there's lots of practice in all of those past paper questions. Go and do them. Each one of them is asking a very similar type of question with regards to your statistics. So you have a great opportunity to really practice it and to really score great marks in your exam on this section. So guys, that brings us to the end of our statistics and transformations for today. I hope you learnt a lot. I hope you're going to go home and practice and really work hard on it. And I once again wish you all the very best of luck for your studies. I know exams are coming up, and I know that you're going to just ace it. So all the best, and I will see you next time. Thanks, guys. Bye.